More than 1 million students are taking admission in computer engineering every year. But only few thousand are getting placed in their dream companies. So what do you think? What is the reason behind this? Actually, this is all about consistency and step-by-step guided preparation. I'm happy to announce you that Ineuron is coming up with DSA foundation course specially curated for product-based companies. So if you are targeting for Mang companies or any other product-based companies, please join this free course. For more detail, check out the description. The classes will start from 24 Jan 5 p.m. Best of luck. Hello everyone, welcome back to the DSA foundation course specially curated for product-based company. My name is Puneet Kansal. I'm the instructor for this complete DSA series. So I welcome you all. Let me go to the chat section. So okay, for the people who have joined this class first time, let me tell you, this lecture is the part of a complete DSA series. This is the part of complete DSA series. Actually, this is the 6th lecture, but you don't need to worry if you are attending this first time. You don't need to worry. Every lecture is independent of each other. Total, there will be 18 classes. In 18 classes, I'm going to cover the complete DSA. I'm going to make your foundation of DSA for product-based companies in 18 sessions. And this is our 6th session. All sessions are independent of each other. So you can come and attend the lecture and you can go. That's it. So you do not need any prerequisite for any of the 18 sessions. Fine. Good morning. Good evening, Mandip. So nice to see you back. Good evening, Satish. Fine. And let me give the brief introduction to our all the lectures. So this is the complete DSA series plan. This is the plan we are following actually. We have already covered the 5 sessions. So if you have missed any of them, you can go and you can check out. You can enroll in this course. This is also available on Ineuron website in the form of a course, complete course. You can enroll over there. The price of the course is 0, and you will get a certificate also if you will complete this course. And this is my surety, you will get benefit. You will definitely get benefit. Either you are a beginner, you will get benefited. Either you are advanced learner, again you will get benefited. And if you want to switch from service-based company to product-based company, this series is going to help you. So these 3 type of people can take benefit from this series. So today we will cover the matrices, and then these are the other topics. The lectures are going from Monday to Friday, 5 p.m. So you can register this course if you have not registered till now. Karthik, hi, good evening. Nice to see you back, you people. Thomas, you are consistent from the first lecture. That's great to see. I promise you people, you will get benefited. You will feel that really this series make some difference between what you were knowing earlier and after this series. Definitely you will find the difference. This thing I can promise to you people. Okay, fine. So let's start with today's session, that is on matrices, means 2D arrays. Let's start with that. So even before that, you can tell me if you have any doubt, anything you want to discuss with me, you can write in the chat box. Islam is saying that, okay, I'm very interested in DSA. This series will be helpful, Islam, for you. Fine, okay, let's start with this session. Let's start with this one. Meanwhile, I will be taking your queries also. If you have any doubt related to this series, you can ask me. I will answer that. Meanwhile, other people can tell me what is the output of this code. Can you check out, please? What is the output of this code? Please check out and reply. Meanwhile, let me reply to the question of Kaushik. Kaushik is asking, sir, मैं पाइथन में डीएसए सीखना चाहता हूँ. Kaushik, in this series, I'm covering the DSA in three languages actually: C++, Java, and Python. So if you are from any of these three languages, you can join this series. Even I will say, even you are from JavaScript or any other language, still you will get benefited from this series. DSA is not about a language actually. It's about logic building. In If you will check out my previous sessions, you will see that the toughest part in DSA, the most important part in DSA is coming up with the best logic which can reduce the time complexity. Writing the code will not in a particular language is not a big task. Let's suppose today you don't know any language. Let's suppose today you don't know any language. Believe me, if you will start learning a language, you will take maximum 1 month or maybe 1.5 month maximum. If you are lazy, if you are going slow, you can take 1.5 month. With a project, just complete the language and you will be good at that language. That's it. You need to know syntax. After that, practice will go automatically. When you will solve the problems, automatically the practice will go. That is not a big task as compared to building the logics. Building logic means solving the same problem in less time. That required, first you need to know the logic. First you need to know the concepts, DSA concepts, and then you need to apply that. Okay, and that should be step by step also. So if you will take like if you are at the first step and you are taking 20th step at a time, so you might lose the interest. So it's better to go step by step, then you will not lose the interest, and yeah, you will be at the top. So yes, this is in this session will go again in C++, Java, and Python. Meanwhile, this code is little bit this code is in C++, but you can replace this thing only. This is a 2D array. You can just think it as a 2D array. If you don't know about vector, it's okay. This is a 2D array. In 2D array, we are just doing something. We are performing some operation, and the people are replying that Karthik is saying that this code is for finding sum of all the elements in the matrix. So he's saying that, okay, we are finding the sum of all the elements in the matrix. Let's see if this is what we are doing. Just simply there is a loop, outside loop, which is going from 0 to n, and there is a inner loop. This loop is inside this loop, which is starting from 0 and going up to m. And okay, n is the number of rows in the matrix and m is the number of columns in the matrix. Fine. So what we are doing, we are checking for the 0th row. This is row number 0. This is row number 1, 2, 3. This is column number 0, 1, 2, 3. So outer loop is setting I value to 0, and then we are changing our j value. So we are actually accessing all these elements. One time we are executing this loop, this inner loop. So what we are doing, just picking the element and putting it, summing up it in this variable, s variable. So yes, we are just adding these elements, and the value of s will be 4 after executing this inner loop one time. And after that, okay, I value will change to 1. So we will come at the second row, add these elements also over here. So this will become 4, 5, 6, 7, 8. All these ones will be added in this. Then I value will be 2. We will be here. We will add these elements. So this will be total will be 12. Then last row we will visit and add these elements. That will be 16. Very simple. Simply we are just adding the elements in the matrix. Just want to go through, okay, how to access the elements inside a matrix. That's it. Just I want to make sure that we know this thing. That's it. Nothing very important in this. Just want to make sure that okay, how we are accessing the elements inside the matrix. This is what I want to ensure. That's it. Otherwise, now let's move on. Now let's move on. Now let's move on with the with building the foundation for matrices. So yes, we are summing all the elements of the matrix here in this code. Fine. So now let's build the foundation for matrices so that once the foundation is there, what we need to do? Practice. That's it. So let me build the foundation for you people. So let's talk about 2D array, or you can say matrices. Matrices are nothing, just a 2D array. Fine. So here we have a matrix. How this is how we declare the 2D array. And what is M here? M is the row. And what is N here? And N shows the column. For example, if we watch this matrix, how many rows are there? This is 0th row. We are starting the indexing from 0. And yesterday we talked why we start the indexing from 0. It's okay if you do not take that lecture. You can take it after this. Don't need to worry. Every lecture is independent from other lecture. Just come, watch that lecture, create that topic and go. If you don't want to watch other also. Fine. So we have how many rows we have. So let me write. These are columns and these are actually here, this side. These are rows. So how many rows we have? 0, 1, 2, 3. 4 rows we have. So value of M is 4. And how many columns we have? 0, 1, 2, 3, 4. 5 columns we have. So let me write 5 over here. 4 rows, 5 columns. This is our matrix. Fine, okay. So we can actually store the matrix in computer. We can access the data actually. We can access the data from a 2D array in 2 ways. We means compiler. Compiler can access the data in 2 ways from the matrix. Or one is row measure order, another one is column measure order. So let's talk about that first. What do you mean by row measure order? How the compiler is actually storing the matrix. How we store the matrix inside the computer? Let me tell you. Actually, either that is 2D array, 3D array, 4D array, 5D array, ND array. Whatever a D array is, that will be stored in computer in the form of 1D array. So 2D array will also store in the form of 1D array. 3D array will also store in the form of 1D array. All the array actually store in the computer in form of 1D array. Let me show you. Let's suppose this is our array. Let's suppose this is our character array. This is our character 2D array. I'm storing some data, characters over here. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T. So I just stored some character in this 2D array. Fine. So how this will store in computer? Let's see. In the form of 1D array. Let me show you. So this is our 1D array, and let me store the elements over here. Let me create first the structure. I'm trying to make some beautiful 1D array. You may not be finding it that much beautiful. Still okay, I'm trying. So how the data will store? If we are storing it in the form of row measure order, if we are storing the data, 2D data in the row measure order, then how that will be stored? That will be stored row by row. So first 0th row will store, then 1th row, then 2nd row, then 3rd row. So let's store the 0th row. In the 0th row, what are the elements? A, B, C, D, E. These are the elements in 0th row. So after that, How I'm just telling how this 2D array is stored in computer. That is stored in the form of 1D array. So row by row we are storing. Row by row, if we are storing, that technique is known as row measure order. That's it. F, G, H, I, J. This is our second row. Let me write. So this is our row number 1. This is our row number 2. After that, K, L, M, N, O. Third row, K. So let me redraw it. K, L, M, N, O. After that, last row, P, Q, R, S, T. Fine. So this is our third row, and this is our fourth row. Row number third and row number 4. Fine. And we have already promised this thing, that the data in array, either that is 1D array, 2D array, 3D array, 4D array, ND array, the data in array stored in contiguous memory location, one after the another, one after the another. So let's suppose our array is starting from 100th location. The start array is starting from 100th location. Then next element is at 101. That is at 102. This is at 103. E is at this memory location. All are contiguous. You can see 105, 106, 107, 108, 109, 110, 111. Fine. So all the elements are stored in contiguous memory location. Fine. There is nothing great in this. Okay, now we want to, so this is how we are storing the data in computer. Fine. Row by row. And if we are storing column wise column, then first we will store the first column, then second column. Like first column is A, F, K, P. Second column is B, G, L, Q. Like this way we are storing. That is that is column measure order. That's it. Fine. Okay, till now everything is clear, I hope. Now let's suppose we want to access the element. Whenever we want to access the element, how we access the, let's suppose, okay, I want to access this element. I want to access n. I want to access n in this 2D matrix. Then what I will write? I will write this thing. I will say that, okay, my array name is A. I'm taking my array name A. And in which row this data is? At the second row. And in which column this data is? At the third column. Fine, very easy. So this is how we access this n. But how compiler actually find out the address? How compiler find out the address of this element? That use this formula. That use this formula to find the address. Directly that is finding the address of this element. Directly that is finding. And that's why we already discussed. Okay, even I am telling right now. That's why accessing the element, accessing any element in the array take how much time? Constant time. You people know. Accessing any element in any array, 1D array, 2D array, 3D array, 4D array, accessing any element take constant time. Because why? We need to just solve one statement. And solving this statement will take constant time. There is no loop here. So solving this statement will take constant time. So let's see how this formula is helping us to find out the location of this element, to find out n into the memory where n is. If we are using row measure order, okay, this formula is actually same as the 1D array, almost same. In 1D array this was the formula. Okay, let me write. This was the formula in 1D array. Base plus index into element size. So if you will compare this was the formula for 1D array. So you can see this is the base, same thing. This is the size, and in place of index we just put this thing. In place of index we put this thing. That's it. And these two things are also similar. Actually, these two things are also similar. Here this index was showing, this index in 1D array was showing that how many elements are ahead of that element. How many elements are just at the front of that element, ahead of that element. Here also, this thing I into n plus j is telling us how many elements are ahead of this particular element. How many elements are ahead of this element? Let's see. You can see here, uh, 1 2 3 4 5 6 7 8 9 10 11 12 13 elements are there which are ahead of this. So this thing will calculate the 13. Okay, and then we will multiply with size of each one, that is 1 byte. And when we will add it into the base, so I'm writing this side 100, then what you will get? 113. And yes, this is the address. This is the address of, and we find out the address. We find out the address of this data. We find the address of this data by using this formula. Let's try to understand now how this formula is working in more detail. Otherwise, we know we need to start from the base address. We need to, this is telling us how many elements are ahead of that particular element which we are finding. Multiply that with the size of the element, that's it, and we will reach to that location. Compiler will reach to that location in how much time? Constant time. In constant time. Fine. So now I'm rubbing it. And let's go in little bit more detail. Let's go in little bit more detail. So if your base will be strong, then you will not face the problem while solving the matrices problem. Actually, what happens, people don't have strong base and they jump to the problem solving, and then they face the problem. They find out new things over there, and then they lose the interest actually because their base is not strong. That don't take that much time. Let's go through it. Let's build our base, and then we will take the product based company problem. Yes, we will take. Fine. So let's see in more detail how this formula is working. Simple. We need to see, okay, this thing I already tell. This thing is telling us how many elements are ahead of that particular element. So how we are finding how many elements are ahead of that particular element? Very easy actually, very easy. How? I just need to find out how many rows are ahead of it. First of all, how many rows are ahead of it? Two rows. How many rows are ahead of this element? Two rows, this one and this one, or you can see here also row 1 and row 2. And after that, some of the element from this row, from the second row, some of the element, if we check out there are some of the element, this one, and other element are from the first row and second row. So this thing is, this I is actually, let me write this I is telling us how many number of rows we have ahead of that particular element. This is telling us number of rows. This is n is telling us number of element in each row. Number of element in each row. Okay. And what j is telling? J is telling how many elements are in the same row which are ahead of this. So elements in same row which are ahead of this element. And if we, now what we are doing, simple, very simple. If we know how many rows are there, two rows are there. Let me write here, two rows are here, fine, ahead of this. And how many elements are there in each row? You can see 5 elements are there in each row. 1 2 3 4 5. So 5 elements are there in each row, fine. And how many elements are ahead of this? You can see 3 elements are there, so let me write 3 also. So if we put this value inside here, so 2 into 5 plus 3 is how much? That is 13. Yes, we need 13 actually here. So that we can add into the 100 and we can reach 113. Yeah, this is working fine. Now let's go in little bit more detail. Let's go in little bit more detail. Let's go. Now what we are doing actually here is nothing. We are just, what we are doing, this part. Let's see what this part is doing. This part only. This part. Let me erase it and write it again. So if we're talking about this part, what this part is telling us, this part is just simply telling us how many rows are ahead of this and how many elements are there in each row. So how I'm getting this data? I is telling me how many rows are there. How I can get this I value? See, this is this I, the element which we want to access. So here I want to access this element. So let me write the I value and J value. So you can see I value is 2. That should be 2. We find out this should be the value. 2 into 5 plus 3. This should be the value. And from I we get 2. Yes. And this I is telling me how many elements are ahead of this. Yes. How many rows are ahead of this? 2 rows are there. And from where we pick n? And I pick from here, and I pick from here. Why I pick n from here? Because n is telling me number of columns. N is telling me number of columns. How many columns are there? 1, 2, 3, 4, 5. Yes, n is 5. N is 5. So we get 5 from here. And from where I'm getting j? From here. So j is telling me j value is 3. How many elements are ahead of this in the same row? Yes, that is also we find the right value. So this is the where from where we are getting the values. Now let me ask you one question. If you people can, let's see if you can connect or not. Let's see if you can find that thing or not. Please brainstorm over that thing. I'm making a statement. You please tell me that statement is right or wrong. You need to tell me that statement is right or wrong. You need to tell me. I'm making a statement. Number of elements in a row. Let me write. Number of elements in a row is same as, you need to tell yes or no. This statement is right or wrong. If you can connect. Number of element in a row is equal to number of columns, number of column in matrix. Is this statement right or wrong? Yes or no? Please write in the chat box. Don't sit idle. Please write in the chat box. This statement is right or wrong. Please reply. Please reply. Let's build our strong foundation. Let's build our strong foundation. Then we will solve the product-based company problems also. But first of all, please tell me this statement is right or wrong. This statement is right or wrong. Please reply. Please reply in the chat box. Everybody, don't sit idle. Think over it and reply. Think over it and reply. Yes or no? This statement is right or wrong? Can you connect it? Can you connect it? Thomas say yes. This statement is right. Thomas say yes. Yes. Karthik say yes. Karthik also say yes. Thomas also say yes. So it's not about square matrix. It's about every matrix I'm talking about. Mandip, it's about every matrix. It cannot be may or may not. It cannot be may or may not. So let's apply over here. How many elements are there in one row? 1, 2, 3, 4, 5 elements are there. So number of elements, what I'm saying, number of elements in any row, either any row, you can pick any row. So number of elements in a row is same as number of columns in the matrix. So number of elements are 5 here. And how many columns are there in the matrix? 5 only. Yes, that will be same. How many columns are there? That will tell us how many elements are there in one row. How many elements are there in one row? Okay, yes, this statement is right. This statement is right. So number of elements in a row is same as number of columns we have. Number of columns we have. Number of columns we have, that will decide how many elements are there in one row. Okay, fine. Yes, this statement is right. This statement is right. That will be right for every matrix. That will be right for every matrix actually. Fine. So that's why I pick n from here, because I know that I want to know how many rows are there. This I is telling me this I will directly tell me how many rows are ahead of this, because the indexing is starting from 0. So with the help of that, I will be able to find out, okay, two rows are ahead of this. Every time this will also be right. I know now how many rows are ahead of this and how many elements are there in one metric, in one row. How many elements are there? How many columns are there? This will depend upon number of columns. So I just simply multiply, and I get how many elements are there in first two rows. Here I get how many elements are there in first two row. And after that I add j to cross three more elements. I need to reach here at this location. I started from base 100 and I need to reach here. So first two rows, just simply, okay, simplest. I'm repeating everything. And if you don't understand, it's okay. You just look at this thing. What I'm saying is that, what I'm saying is that how this formula is finding the location of particular element. Simply that is starting from the base, okay, and that is passing number of elements ahead of that, and how many elements are there, just multiplying with the size. So size is 1 byte here because this is the character array. So we reach to this location, and if we go in more detail, this is telling me how many rows are there and how many elements are there in each row. So I will pass these two rows with the help of this part, and with the help of j I will pass these three elements. So these number of element 10 elements I will pass with the help of this thing, and these three elements I will pass from with the help of j, and then I will reach, yes, I will reach to n. So this is how this formula is working. This is how this formula is working. This formula is telling us how to find out a particular location, and we can solve this formula in constant time. So yes, we can find out the location of any address. We can find out the any element in constant time. We can find any element in constant time. Fine, okay, fine. Don't worry. Be with me, and slowly this will be easy for you. And this is the base actually. Uh, Later you will not face the problem. If any doubt, you can ask me. Keep asking the doubt. If any doubt, Yuvraj is asking something. Let's see. Sir, that will be the same in. Okay, can you give me the example, means what type of array you are talking about? Hmm. Example, give me, Yuvraj. I will come to that. Fine. Meanwhile, let me ask you one question. Let me ask you one question. So here this formula is used when we are using zero base indexing. Let's see if anybody can reply. So if we are using zero base indexing, then we use this formula. What about if we are using one base indexing? What about, let me erase everything. Let me ask the question. This formula is for if we are using zero base indexing. What if we are using one base indexing? What if we are using one base indexing? Then how we need to modify this formula so that this can find out the location of any element. So like in the case of 1D array, we modified it like this. If you remember from the yesterday class, we just subtracted 1 from the index, that's it, and multiply with the size. So this was the modified formula for 1D array, for the 1D array. Okay, but what about the 2D array? 2D array, how you can modify this formula so that the formula start working for one base indexing rather than zero base indexing. So you will find out many problem on lead code or code forces where they will mention this thing, where they say that, okay, that indexing is starting from 1, indexing is starting from 0. So if you're logically understanding what I want to say, don't need to cram this formula. I don't want you to cram this formula. If you will cram it, you will not be able to solve those problems. If you will understand it, how actually we are finding that location, if you will understand it, if you will logically understand it, if you will be able to connect logically, then based upon the question, you can also modify the things here. And if you are cramming this thing, okay, with the help of this formula we can find out the address, that's it. Then every time new problem will come, you will not able to find out the solution. Every time new problem will come, they will twist little bit, and you will get stuck. They want to check this thing only, You really understand the things or you have crammed the things? Okay, so anybody? So we come up, yes, we come up. So no, if we Bharat is saying, okay, what about if we have for every row there is a different number of elements? No, for that one this will not work. For that one this will not work. Okay, we are talking about the complete matrix form. We are talking about the either in the form of rectangle or square. So we are talking about that. So we come up with one solution from Mandeep. Mandeep says that this formula will work. So let's see which formula is sharing, that will work or not. Let me copy it, base plus, let me copy it from the screen. So he's written I plus 1, I plus 1 into n and plus j into size. So let's suppose I want to find out this location. So this location is 2 and 3 and 4. 3 and 4. Let me find out if I can reach over here or not. So base address is, let's suppose, 100 plus I value is 3 plus 1. According to this formula I'm just putting. N value is how many columns are there? 1 2 3 4 5. 5 columns are there, plus j value is 4 into size is 1. So let's calculate it. 100 plus 3 plus 1 is 4. 4 into 5 is 20. Here we get 20. 20 plus 4. Okay, and this will be 10. Sorry, it's not 20. Yeah, it's 20. 20 plus 4, 10. 124 actually. This will not be the address of this location, because let's suppose this is 100. This is 101, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The address should be 13 only. 113. 113. Okay, I don't write 11. So you can write. Okay, sorry. So 102, 103, 104, 105, 106, 107, 108, 109, 10, 11, 12, 13. And according to your formula, we are getting 3 plus 1, 4, 124. No, this is not working anymore. Although this is, you can modify it, that might work. Otherwise, okay, let me try at my end. So okay, how I can come up with the modified formula from this. So here the indexing was starting from 0. Okay, so earlier if you notice that the value here is, if I write the indexing with 0, let me write 0 1 2 3, 0 1, let me write here 0 1 2 3 4. So this is 0 base indexing and this is 1 base. Earlier here the value was 2. Now, but here in 1 base indexing the value is 3. So rather than adding, we need to subtract. We need to subtract. So if what if I write I minus 1, because I need 2 here. I need to pass how many elements? I need to pass 13 elements. So I minus 1, because I value is 3 in 1 base indexing, so I can write I minus 1. And L value is, okay, how many elements are there in one row? 1 2 3 4 5. Number of elements are same, so N, yes, this is same. And after that, 3 elements I want to pass on. 3 elements. So earlier I was using this J. So earlier the J value was how much? The J value was 3. The J value was 3. But right now the J value is 4. So what I can write? I can write J minus 1. I can write J minus 1. That's it. That's it. This is the new formula we can generate. So why I'm telling you this stuff is that, because there will be many questions you will see on lead code and code forces. You will see that, okay, they are talking about 0 base indexing, 1 base indexing. And if you will go to medium to hard problems, and if you will be knowing this base, if you will be really understanding how you can find out a particular element in zero based indexing and one based indexing, then you can play with hard problems also. You can play with moderate problems also. I hope how many people are able to connect with this formula? Please confirm me. Please confirm me how many people are able to find out that okay, this formula is working fine. Please confirm. Please let me know how many people are able to connect. Or you can ask the doubt also anytime. Please ask the doubt. Your doubt will help other people also. Okay, +1 from Bharat and Mandeep. So any doubt you can ask me. And yes, this formula will work fine. Let's check out if this is working fine or not. And then we will move on. So 100 plus I value is how much? 3. 3 minus 1 is 2 into this is 5 actually. And plus j value is 4 minus 1, 3. Yes, this is working fine. You can see 10 plus 3, 13. 13 I'm adding into the 100. So yes, we reach to this location. In one base indexing, we can use this formula. In zero base indexing, we can use this formula. That's it. That's it. So this is about the row measure order. How we are accessing the elements. How we are accessing the elements into row measure order. How, if the data is stored in the form of row measure order, how we can access a particular element. Fine. So this might be a little complicated, but this will really help you later on. Second method is the column measure order. So in column measure order, you can use this formula. So you can drive it yourself again. Now you don't need to know. You just you can see here. This is telling me how many elements are ahead of it. How many elements? Let's suppose this element I want to find out. 0, 1, 2, 3, 4. These are the columns, and this is the row. 0, 1, 2, 3. I want to reach here. So if I'm storing in column measure order, so this column will store first, then this column, then this column. How many columns are there? J is telling me. J is telling me number of columns. So yes, let's suppose this element I want to access. So 2 of 3. 2 of 3. So is there 3 columns ahead of this? Yes. 1, 2, 3. Yeah, J is telling us the right answer. And how many elements are there in each column? So again I can make a statement. Number of element in each column will be equal to number of elements in the each column will be equal to number of rows in matrix. Number of rows in matrix. So M is what? See, number of rows. This is row, this is column. So M is telling us number of rows, and number of rows is telling how many elements are there in each column. So just I pick this M from here. And after that, how many elements are ahead of this remaining element? These 2. So I value we pick from here. Yes, I value is 2. So I just want to tell you is that everything is logical. You need to understand the things logically. You should not cram the things. If you will cram the things, then they will make a twist in the question. We will not be able to solve. So I hope you are able to connect how we can find out the particular element in a 2D matrix. I hope you are able to find out this thing. If any doubt, you can ask me. If you are facing any doubt in this, you can ask me. Otherwise, let's move on. Any doubt, you can ask me. Otherwise, let's move on. So now let's see if we really get the concepts or not. Let's see. So let me erase the board and let's move on. Let's move on. So one more information if you want is that okay. C, C++, Java and Python use the by default row measure order to store the matrix in computer. C, C++, Java, Python use the row measure order, and by default there is a scientific language, MATLAB, that use the row measure order to store the data into the in the form of row. By default, that store the matrix in this form, in the form of 1D array. 2D array will be converted. That definitely will be converted in 1D array. But in 1D array also that can be stored in row measure order or column measure order. So C, C++, Java and Python store by default in this, and MATLAB store in this. Although in question they can ask us, okay, store the data in column measure order. Then we need to know the stuff. Fine. So now let's practice. It's practice time, yes. It's exam time. Let's see, let's check out our knowledge if we really understand the matrices basics or not. So are you ready? Are you people ready? Ready or not? Yes or no? If ready, then try this question. Can you try this? Let's see how many people can solve this problem. Let's see. Let's see how many people can solve this problem. Let's see how if you can solve this or not. Try everybody. If you can solve this problem, then you really understand what we have discussed till now. You 100% that will be confirmed. That will be confirmed. The important part is you are trying or not actually. The important part is you are trying or not. Actually, DSA is the subject which is more about doing the practice rather than just taking the lectures. Taking lecture will not create the big difference. That will you will get 20% benefit only. If you are consuming some videos and you are consuming the DSA directly by taking the video, then you will learn the DSA 20%. But if you will try it, if you will practice, then 80% will be more added. 100% then you will be good at DSA. Practice, and that is the missing point. That is the missing point due to which actually people are not getting placed in product based company. This is the only reason actually. Even they are doing practice, they are not consistent for, I will say, 6 months. And this is the main reason. That's it. Can you tell me what is the answer? Can you tell me what is the answer for this question? Anybody? Hello, hi Vikalp, nice to see you back. It's really look nice when we see the same people are coming to the lecture. Nice to see you back. Can you try it, Vikalp? One answer from the Mandip. Okay, we get one answer. So let me explain the question at least now. So let me clear one thing. This is what is the size of this array? Let me write it more clearly. The size of this array is 10 and 15. So 10 rows are there, 15 columns are there. Fine. And if you will notice carefully, this is one base indexing. This is one base indexing. It's not zero base indexing. See, this is showing one base indexing. This is showing one base indexing. So this is one base indexing. Okay. They are saying that array is stored in row measure order. They provide us the base address and they provide us the size of the each element, that is 1 byte. They are asking, can you find the address of this element? They don't provide us the value of I and j. They provide the value of, okay, I can say m and n. If we check out the previous slide, then there this m was showing number of rows. How many rows are there? 10. How many columns are there? 15. So let's see, okay, if we can find it. So now this time we need to use which formula? We need to use the one indexing base formula. Okay, in which we so what was that formula? I minus 1 into I minus 1 into, okay, n plus j minus 1 into size. So I'm going through formula, then I will go directly also. You do not need to cram this thing, but still, okay, I'm going through it. First, let's check out. Base address is 100. Base address they provide is 100. Fine. I value they don't provide. I and j value. Fine. It's okay. Let's leave it as it is. N value we know. So this is the 15 plus j value we don't know. j value we don't know, j minus 1 into size value is 1, size value is 1. So let's solve it. So this is 100 plus, how much is this, 15I minus 15, 15 is multiply here, plus j minus 1, okay, into 1 is just nothing, into 1 is the same thing. So now we can write it 100 plus 15I plus j minus 16, and if we subtract 16 from 100, then we will get what, 84, 84 plus 15I plus j. So let's see if this is matching with someone. 15I, okay, 15I is here and j is here and 84 is here. Yes, the answer is A. Answer is A. You can rewrite it like this: 15I plus j plus 84. Yes, we, the answer is A. Answer is A. The only motive for this question is that, okay, you really understand the how we can access the data in 1D array. Sorry, how we can access the data when the indexing is one base indexing, one base indexing. So if you have tried, now you must have understood this thing, how, what we are doing, what we are doing. So this is the, if you are cramming the things, then this will be difficult. Okay, fine. Okay, the motive was here is that we need to know row measure order and column measure order, one thing. Second thing, we till now we discussed is the thing is that if you really understand one base indexing and zero base indexing, okay, how we can access the element one base indexing and zero base indexing, that was important, that was important, that's it. Otherwise I just tell you nothing. I just discuss about the row measure order, column measure order, zero base indexing, one base indexing, that's it. You must have idea about that. So let's move on, don't need to worry about all little math about it. So now let's solve one problem. Now let's solve the problem. This is the problem from the Uber, which pay one, which is famous for paying 1 CR packages. So let's see what type of problem they ask actually. So can you tell me, please try it. So that will be important. You need to try. Can you tell me? So let's try to solve this problem. I just want that you people solve this problem. Tell me what is the output for this input. Check out the problem statement. First step is if you really understand the problem statement correctly or not. That is the first hurdle. So let's see how many people are able to reply. If you will solve this problem yourself, you will get more confidence. If I will solve, then you will not get that much confidence. Keep trying, and the moment you will start solving this yourself, you will be in that company. That's it. So these are not my questions. I am taking from the product based companies now. So tell me what is the output. Keep trying, keep replying, please. That is important. That is important. Keep trying, keep replying. Keep trying, keep replying, please. What is the output for this particular input 1 and input 2? For both, you can tell. This is the first. They provide us 2D array here also and here also. So this you can write like this: 3, 2 and 1, 0. So this one 2D array is this, one 2D. For first one, okay, what should be the output? We get the answer from Bharat, from Karthik, from Thomas. They are saying that the output here is 8, the output here is 0. Actually, let's see the problem statement. The problem name is count negative numbers in a sorted matrix. So they provide us a sorted matrix and they ask us to count the negative numbers. Actually, let's see. They provide us a matrix of m by n size. So m rows are there and columns are there. They provide a matrix named as grid, fine, which is sorted in non-decreasing order. Non-decreasing means decreasing order, but there will not be any equal elements. Decreasing, non-decreasing matlab which is decreasing. Non-increasing means which is decreasing. Just decreasing. You can replace it with decreasing. Decreasing where equal to is not there. Elements are not equal. Decreasing 5, 4, 3, 2, 1. That is non-increasing, or decreasing 5, 4, 3, 2, 1. Fine. So they provide us which is sorted in non-decreasing order, both row wise and column wise. So if you will see, this row wise elements are in decreasing order, and if you will see in column wise, the elements still are in decreasing order. Any column you can see, any column you can see, and any row you can see, all the rows are in decreasing order. So yes, they are in decreasing order. This type of matrix they provide us, and they ask us return number of negative numbers in this matrix. How many negative numbers are there in this matrix? So 1, 2, 3, 4, 5, 6, 7, 8. 8 negative numbers are here. And what about this? There is no negative number, you can see. 0 is not a negative. So there is no negative number in this matrix. So the output for the second input is 0, and for the first one is 8, second one is 0. Fine, okay. So I hope you understand the problem. Simply they provide us a matrix in which the rows are sorted in decreasing order and columns are also sorted in decreasing order. All the rows, all the columns. You can check out all the rows, all the columns. Fine. So this is what they provide to us. Now, how we can count number of minus ones? Any idea coming to your mind? Please think over it. That is the learning part, if you're thinking or not. If I'm telling, that will not create a big difference. If you're thinking and replying, that is the real learning actually. That is the way to learn the DSA actually. So can you please reply? You can give me the idea. You can write the code also. You can find out that this same problem on, you can write count negative numbers in a sorted matrix, lead code. You can find out this problem on lead code. I take it from lead code only. Or you can just write a pseudo code. You just give me the idea, sir, do like that. In English you can write like Vikalp write for us. Vikalp says that by two for loops, checking the condition, if it is less than 0, then increment by 1. That's it. That's it. So we come up with one solution. That's great. And that is the great idea. Share your solution which is coming to your mind. Any solution coming to your mind, just share immediately. Share with the interviewer. Whatever is coming to your mind. Bharat and Vikalp share the same solution actually. What is coming to our mind? So if somebody asking me, which are the negative number here, I will start from here. Is this negative? Is this less than 0? No. So I can see, okay, I can set a count from 0. So is this 0? Is this less than 0? No. Is this less than 0? No. No. Yes, this is less than 0. So I make it 1. Next one, next one, next one. This is less than 0. So make it 2. Next one, next one, next one. They say this and this. 2 more. Next one, next one, next one, next 4 more. So 8. So one by one we can increment, means one by one we can increment. So what is the idea? Just make 2 loops. Outer loop is going through row by row, first row, second row, third row, fourth row. Inner loop is going through, okay, how many elements are there in each row. You are going through each element and you are checking, okay, if you are finding any element which is less than 0, then you can say that, okay, the time, you can count it. You can count it, okay. You can simply write 2 loops. One is, this is for the number of rows. How many rows are there? M rows are there. And you can write another loop inside it, which is checking for columns. How many columns are there? N columns are there. Sorry, J plus plus. And what are you doing? You are counting by making a condition that if in the matrix name is grid, if in the grid at ith and jth location, if the whatever element is there, if that is less than 0, then you will increment your count. That's it. And you can set the count to 0 initially. That's it. So this is the code shared by the Bharat and Vikalp. Fine. Yes. This is solving the problem. We are finding all the negative elements in this. But why these people who are paying 1 CR to us, really will ask this solution? Actually, next question will be like, can you solve this problem into n plus m time? This is taking n square time. This is taking n time. Okay, n into m time. This is taking m. Fine. Let me write it again. So this loop is taking m time going up to m. This loop is taking n time. So the time complexity for this idea is m into n. So this is the time complexity. But they are asking for m plus n. So how you can improve it? They're asking for this. Then only they will pay us the good salary. They will not pay for this thing. Yes, we need to start from here only, but in the interview, we can start from here. Meanwhile, we are solving it, the ideas may be coming to our mind and we can share that immediately. Okay, this is how we can improve it. Any idea coming to your mind, how we can reduce this time complexity, any other idea, how you can find out all the negative numbers in this much time. How much time is this? This is the number of rows plus number of columns. So in this case, number of rows are 4, 4 plus, and number of columns are again 4. So in 8 steps, the loop can go up to 8 step only. The loop cannot go 4 into 4, 16 steps. So one thing is confirmed. One thing is, from here you can check out one thing, because you can go 8 steps only. You can go 8 steps only. Then you cannot check all the elements. Total number of elements are 16. So you cannot check all the elements. If you will check all the elements, that the complexity will reach to n square, you can say, or you can say m into n. But you need to, maximum you can go, you can access one row and one column. This much element you can access. So you are not allowed to go through all the elements. So somehow you need to skip the elements. Somehow you need to skip the elements. And they have given us one thing, one clue they have given us. These rows and columns are sorted. They are sorted in decreasing order. They are sorted 4, 3, 2, -1. Might be we can take some idea from here. Might be we can take some idea from here. Might be that can help us somehow. We cannot check out each and every element. If we will check each and every element, the complexity will reach to n square, or you can say m into n. So we cannot check each and every element. Because the elements are sorted, they can help us somehow. How they can help us? Okay, I'm just giving one idea and you can keep thinking. That is important. Okay, can I make one statement? Okay, let's suppose I'm talking about this element. I'm talking about this element. Please help me in this. Please help me in this. I'm talking about this element. You please help me in this. If this element is -1, I'm making a statement. If this element is -1, can I say that all the elements in this row, will be negative only? If this element is negative, then can I make a statement that all the elements in this row will confirm that will be negative? Is this statement right or wrong? Is this statement right or wrong? Okay, I'm going through your ideas, other ideas also. There may be other ideas also. But right now, okay, let me give me the answer of this question first. Yes or no? Yes or no? If this element is negative, will all the element will be negative? Is this confirmed? Yes. Yes, that will be negative. Okay, I'm coming to your, I will take Vikalp your idea also. You are taking, okay, convert 2D into 1D, and maybe some people are saying, okay, we can use, Bharat is saying that, okay, we can use binary search. I will come to your ideas also. So before moving to that part, okay, let's go through this idea first, which I want to share. Okay, then I will go through your idea. Then we can compare, and this is the way. Then we can compare. Okay, which idea is working better way, which is taking less time. Then we can go with that. That's it. So I am just what I want to do is that, according to me, what I want to do is that I want to skip the elements. And there one thing is coming to my mind, that let's suppose if I'm taking this element, let's suppose I'm taking this element, then if this is negative, then I do not need to check all these elements. I do not need to check all these elements. I'm confirmed they will also be negative, because the elements are in decreasing order. So if this is -1, the next one will be even smaller than that, smaller than that, smaller than that. Okay, fine. So okay, what about if an element is positive? Now what about if, let's suppose this element, if this element is positive, can I make a statement? Can I make a statement that, okay, all the elements which are in this up to here, all the elements up to this element in that column, all the elements, if this element is positive, then can I say that all these elements will also be positive? Can I make this statement or not? Yes or no? Can I make this statement? Keep thinking and keep replying. That is important. Let me erase the comment. I will come to the ideas which is shared by you people also. But before that, okay, can you tell me this statement is right or wrong? Yes or no? Yes, this statement is right. Okay, maybe little bit we must be getting little bit idea from here. So okay, let me share one idea from my side now. Let me share one idea from my side. You people please verify that thing, is that is right or wrong. I'm sharing one idea. The idea is like this. I will start from here. I will start from here. Okay, I will start from bottom left corner. I'm starting from bottom left corner. Fine. After starting from bottom left corner, if I'm finding a number which is, if I'm finding a number which is negative, if I'm finding a number is negative, then what I can do, I can say that, okay, my count, let me set my count. So what will be my count? I will count all these elements. I will count all the elements in that row. How many elements are there? Okay, let me count directly right now. After that, we will write in the form of code. So 4 elements I count, because this was a negative. I know that all the elements in the same row will be negative. That will be negative. So I just consider them directly without going over there. I count directly. Fine. And after that, what I will do? After that, what I will do? I will go upside. I will go upside, because maybe now I will go upside. I will go upside. So I have two options actually. I can go upside or I can go this side. I can go to the right side. So I will not go to the right side. If you can check out, you please keep verifying. I will not go to the right side. Why? Because I have already considered all the element. Why I need to go again here and count these? Why again check them? Yes, there might be some element upside which can be negative or which may not be negative. So this element may be negative, may not be negative, because this is in decreasing order. So this element may be negative, this may not be negative. So I will check this element. I will check this element. So I will check, is this negative or positive? Again, I'm checking. If this element is negative, it's positive. This element is positive now. This element is positive. Okay, this question answer you need to give to me. This is the last question I'm asking from you, and then I will summarize this problem. Last question I'm asking here. If this element is positive, if we find out positive element, then we have to move right side or upside. So we have to check this element or this element. Which element we have to check out? Right side or upside? Please write in the chat box. Think over it. You need to reply to this. You need to reply to this. What you think? What is the what will be beneficial? Either we go to the right. If we get some positive number in this matrix, let's suppose this is the positive number we get. So should we check this one next time, or should we check this 3 next time? Either we can go to the right side or we can go to the upside. These elements we have already counted. The moment we find -1, what we are doing? We are just counting all the elements after coming, which are coming after in the same row. After that element, whatever the elements are coming, we are counting all of them. Yes, we have done that. But what about the positive also? Last case, if we encounter with positive case, positive element, should we go to the right side or should we go to the upside? Let's suppose if I will go to the right side actually. I will go to the right side. I will go this side. Why I will go this side? Why not up? Because if this element is positive, I'm again making a statement. If this element is positive, then all these elements will be positive. If this element is positive, all these elements will be positive. We are not searching for positive elements. We can skip this. We need to skip. We need to skip the elements. Otherwise, how we can solve this problem into this much time? If we are checking each and every element, that will reach to n square time. But we need to reduce that. To reduce that, we need to skip the elements. And what is the idea of that can comes to my mind is how I can skip? I can take the benefit of sorted array. I can take the benefits of sorted array because I know that the column is sorted. The column is sorted. So if this is positive, if one is positive, then confirm upper element will be positive because this is in decreasing order. The column wise we are decreasing, row wise also decreasing. So because this is in decreasing order, confirm this element will be positive. We do not need to go there and check. They are positive. Where we will move? We will move this side. And this is the same method we will keep, same these two steps we will keep repeating. If we are getting negative, what we need to do? And what if we get positive, what we need to do? I'm starting it again. So we understand the two steps. If we get negative, what we are doing? So we are just counting how many elements are there in that row. We are adding that in our count. So we are incrementing our count. Okay, we are incrementing our count. How many elements will be there? If total number of columns is, how many columns are there? N. And how many elements will be there? So that depend upon okay, on which column we are right now. So let's suppose we are on column number 0. We are on column number 0. Then from this we can calculate. Okay, let me keep it easy little bit right now. So if we get negative, then one thing is confirmed, all elements are negative. So how many elements are there? 4. And then what I will do? I will move upside. Upside I will move. Fine. If I get positive element, like here I get positive. So because I get negative, I count all the elements and I move up. Because there is no use of moving this side because we have already calculated all this. So I move upside. After reaching here, if I get positive, what I need to do? If I get positive, one thing is confirmed, in that column, all the elements will be positive. So no use of going up. So let me move to the right side. So what I will move? I will move to the right side. I will move one step to the right side. That's it. This is what we need to do again and again. So after coming here, so let me do it. After coming here, we get positive. What we need to do? Move to the right side. I move to the right side. I will use this formula, this algorithm. So now I get negative. So whatever the element are there now, remaining element in this row, I will count them 2. So I add it, total is 6 now. And after that I move up. I move up. I reach here. So now I get positive. So what I need to do? I just need to move to the right. So I move to the right. And when I get negative, I count all the elements. After this, how many elements are coming? 1 only. So I counted this also. And after that, I move up. Again, I get negative. So I count all the elements. How many elements are there? 1. So 8. That's it. And the moment we cross this matrix, actually, after this, there is no row and there is no column. No row, no column. So we can stop then. And this is our count. How many steps we have taken? If you will see, let me show the steps also. How many steps we have taken? See here. We started from here, 1 step. After that, we move here, 2. After that, we move here, 3. After that, we move here, 4. After that, we move here, 5, then 6, and then 7. So in 7 steps, we check out how many elements are there. In 7 steps we check out how many elements are there. That's it. In 7 steps. And what is the idea we are using? We are getting the benefit of the sorted arrays. We are getting the benefit of, this is the algorithm. That's it. This is the algorithm. How many people are able to connect? Please write in the chat box. How many people are able to connect with this idea? Then I will discuss about binary search also, and whatever other idea you or might be sharing. People are writing +1, so they are getting the idea. Okay, let's implement it first. Let me write the pseudocode for this first. Let me write the pseudocode. So if you are not able to understand till now, it's okay. Even with the pseudocode, that will become more easier. Little bit you must be getting, little bit. That is more than enough. So let me write the pseudocode for this. So I need a variable count, which will count how many negative numbers are here. Fine. What I need to do? So now I'm saying that I will start from this location. I will start from this location. So which location is this? Which location is this? So which row number? Okay, let me write. If I'm talking about row, this is the n-1th row. This is the, okay, let me write. Number of rows are m. So let me directly write m-1th row. Because indexing is starting from 0. 0, 1, 2, 3. So m value is 4 and n value is also 4. So this will be third row. Yes, this is the third row from where I'm starting. And from which column I'm starting? I'm starting from 0th column. This is in 0th column and third row. So let me write 0. So I'm starting from 0th column. Fine. Now what I need to do? So what we discuss, if this is a statement what we discuss. If in our grid array, please be with me. In our grid array, we are checking, okay, in this row, in third row, I mean to say, in third row, and in 0th column, actually I'm accessing this element now. This we have already discussed. If this data, if this element is smaller than 0, means that is negative. If this element is smaller than 0, that means that is negative. What we need to do? We already discussed. What we need to do? I need to consider all the elements which are coming after this. So 4 elements are there. So actually I can count it. I will increment my counter. Count equal to count plus what? How many elements will be there? So total number of how many elements are here? That depend upon number of columns. How many columns are there? N. 4 elements are here actually. So I can write, okay, n, but I cannot write n when I will be here. Then number of elements will be 2. So what I can do? I can subtract from here. In which I can subtract, okay, in which column right now I am? In which column right now I am? So if I'm at the 0th column, then I can see 4 minus 0. 4 elements are there. I will add all of them. If I'm at the 2nd column, so what I can do? 4 minus 2. 2 elements I will add. Yes, 2 elements I will add. So this is working fine. This is working fine. So simply, if you don't understand even, simply we are counting how many elements are there. This is what we discussed. This is what we discussed. And after this, you know that we counted all the elements and we need to go up. We need to go up. So for going up, we need to decrement our row. Row minus minus. Row, we will be at this now. Earlier, we were at the last row, m minus 1. That's it. This is for the negative. If we are less than 0. Else means if we are greater than 0 or equal to 0, then what we need to do? You know that if we have positive number means, I can write this statement even. If I can write this again, otherwise we don't need to write. Just for understanding purpose I'm writing, because this is the positive number. So row and column, if this is greater than equal to 0, okay, means this is a positive number. If positive number, you know that what we need to do? If this is a positive number, just shift to the right side. means decrement the column, increment the column. Column earlier was 0, now the column will be 1, column will be 1. So column plus plus, right side shifting means column incrementing. That's it. These are the two steps we were doing, one for negative, one for positive. That's it. And this we need to do again and again until unless we are going out of the matrix. So we can put inside the loop, and in this loop actually, until unless our row, number of rows become, starting from last row and until our rows is greater than 0, until our rows are greater than 0, or and either we cross the row or either we cross the column. So column we start from 0 and until unless our column is less than n. Total number of columns are n. Small n you can write, okay. Small n you can write. That's it. That's it. And after that you can return total number of negative numbers. That's it. This is what we discussed. This is what we discuss. Any doubt in this you can ask me. So Vikalp, I will come to your idea also. Please explain it little bit more. So like converting from 2D to 1D, and after that what? After that what? So we convert 2D to 1D, and after that what? So meanwhile you can write that, and meanwhile I can code this. So you please write your idea, little bit explore little bit more, and the people who were writing in binary search, they also please write little bit in more detail so that we can discuss that. And meanwhile, okay, let's try to code this. We will go in more detail actually, but before that let me try to code this. I'm going to lead code with this is the same problem. I just picked this from lead code, you can see over here. Okay, let me erase this. So this is the same problem on lead code, you can check out. You just simply write count negative numbers in a sorted matrix. Even this problem is asked in many companies. You can see in Amazon, Bloomsburg, Microsoft, Apple, Uber, and Yahoo. So many companies this problem is asked, and this is the same statement I have taken from here only. And let's see, let's do the same thing what we have discussed. So let's take a variable which is to count how many negative numbers are there. After that, let me set from which row I am starting. From the last row I am starting. So the name of the matrix is grid, and how I can get how I can reach to the last location. So I just will use the size function. So grid dot size is giving me in C++ is giving me the number of rows, and because the indexing is starting from 0, so I will write -1. So row, I have reached to the last row, and column will be 0. Column is 0. So we are accessing, we know that we are accessing the 3rd row and 0th column. Fine, fine. And after that, just what we are doing, we are making a loop here. So let me just write the loop. Even before the loop, you can write that. Okay, you can write the statement if in our grid array, if you check out your element at that particular row and column location, if that element is smaller than 0, if that element is smaller than 0, means that element is negative. If that element is negative, then what you need to do? You need to increment the count. You need to increment your count, and you need to decrease the row. So let me do that. Count is equal to count plus, we already discussed, okay, total size minus column. So total size, let me calculate how many columns are there, how we calculate number of columns. So that is calculated with the help of size function we can calculate. So total number of, this will tell us how many columns we have. So this is how we find out, okay, number of columns in C++. Okay, how we find out number of columns. Let me write over here. Number of total columns in grid matrix. Okay, and this is telling me initial position of row, and this is telling me initial position of column. Fine, okay. So we simply find out total number of columns and minus column. So this is telling me how many negative numbers are ahead of me. And after that, okay, and what we were doing, we were decrementing our row. We are going upside. We done this, and after that we can write else. And in else, what is the condition? Even you don't need to write, but still, okay, for clarity I'm writing. If grid of row, if the element is positive, that's it. If the element is positive, so let me write. When the element will be positive, that will be either greater than or equal to 0. So that will not be negative. If that is not negative, then what we need to do? We just need to move to the right side. Moving to the right side means incrementing the column. So we move to the right side. And these two steps we need to repeat again and again. We need to put these two inside a loop until unless we either cross the, until unless we our column is less than number of, if column is less than n and our row is greater than equal to 0. That's it. So this is what we discuss actually. And after coming out of the loop, we can return our count. Yeah, that's it for this. This is the closing function, and that's it. So let's try to execute. This is what we have discussed actually. This is the same code what we discussed. Simply the same code, means this is for negative, this is for positive, and repeating it until we are going out of the matrix, either through columns or either through rows. So we are decrementing the row, so we are going up to 0, starting from m minus 1, and here incrementing the column, so starting from 0 going up to n. Okay, let's run this code and check out. So let me submit this code. Yeah, it's working fine. The same thing what we discussed. And can you tell me what is the time complexity for this code? Can you tell me what is the time complexity for this code? Or any doubt here? Any doubt or time complexity? Let's first discuss this problem, this solution. Then Vikalp, I will come to your one. And I think Bharat also shared a little bit about the binary search. Yes, we can apply that approach also. We will talk about that. But first, let me know how many people are able to understand this thing. How many people able to understand this code? Please write in the chat box +1. If you are able to understand, please write +1. Please write, please confirm me if that is clear to you or not. Or any doubt you can ask me. If any doubt you are facing, ask me. Otherwise, +1. So that we can move on. Any doubt coming, ask that doubt. That should be clear. Otherwise, I will ask lots of questions then. I will ask lots of questions from you people. Okay, and what is the time complexity here? What is the time complexity? So how many times this loop will be executing? How many times this loop will be executing? So you can see that, okay, either every time you are either going to the upside, row minus means upside, or you are going to the right side. So you are going like this, either right side, upside, right side, upside. So maximum how many steps you will take? M plus n. How many steps you will take to cross the matrix? M plus n. So this loop will go up to m plus n time. Yes, we find out how many negative elements are there into our matrix in this much time, in this much time. If you understand this thing, if you really understand, let me ask some questions from you people. Let me ask some question from you people. So let's check out, you really understand or not. You please answer. That will also increase our logical thinking skill. That is required. That will need time. Problem to problem, that will improve. So one thing I start from here. First question arise here is that why I started from here. Why I, or even I can see, okay, I start from this corner. I could start from this corner, or even this corner, or even this corner. Okay, let me talk about them. Maybe see, first time we are checking out this thing, how we are coming up with this idea. This is important to know. Let's suppose I'm starting from here. Let's suppose I'm starting from here. Okay, let's suppose we are starting from here. Let's see if we logically understand the problem or not. If we start from here, then what I need to, the idea is that I want to skip the elements. I want to skip the elements because I cannot check out all the elements. If I will check all the elements, then the complexity will reach to m into n, and we need complexity m plus n. So I want to skip the elements. So let's see if I can skip the elements if I'm starting from this location. So let me see. If I'm getting negative, if I'm getting negative number. So can you people tell me, if I'm getting negative number, can I say that all these elements will be negative? All the elements in the same column will be negative or not? Yes or no? Yes or no? If this element is negative and this is in sorted order, decreasing sorted order, decreasing. So can I say that all the elements in this will be negative only? Yes, yes, Mandeep, that will be negative. So I will just, what I will do, I will set my count. This will be 4 in this case. And we know that, okay, how to find exact value, count plus n minus column, like that. We will implement that later on. But first, okay, again. So I will count this. And after counting this, should I move downside or should I move to the left side? Should I move to the downside or left side? You people please keep replying now. So this will tell us you really understand the concept or not. Please reply. Move left or move down. So Mandeep and Karthik are saying move left because they know that there is no use of coming down. We have already calculated, already we have counted these minus ones. We don't need now. We can move to the left. So moving left means column minus minus, column minus minus. So these two things we do. Another thing is if we find out positive. Now see, we find out positive. We find out positive. If we are finding positive, can I say that? Can I say that? If this is positive, then all these elements will be positive. All the elements which are at the left hand side in the same row, all these elements will be positive because this is in decreasing. This is in decreasing. Elements are in decreasing order in rows and in columns. So these elements will be greater definitely than this because this is in decreasing. So yes, these all will be positive. And if all are positive, we do not need to go over there. Where we need to go? If we get positive, just come down. Coming down means row minus minus. Coming down means from this row, row plus plus, from 0th row to first row. That's it. Done. Done with the, yes, if we will start, I can say one thing now. If we will start from this place, again the logic is working. Again the logic is working. Okay, let's write the complete code. Let's write the complete code for this. Let me write here in the form of little bit pseudo code. You people please keep helping me in this. That is required. So we can take a counter. Our count will start from 0. And you people tell me, now this time you need to tell me, what will be the row value? What will be from which row we are starting? I want to start from this element. So what will be the row value? Please keep helping me now in the chat box. You need to help me. Otherwise learning will not happen. If I will be keep writing, then learning will not happen. If you will think and reply, then only DSA will come to you. Otherwise that will not. What should be the value of row? I want to access this element. this element. Karthik says 0. Yes, Karthik. This is in 0th row. This element is in 0th row. Yes. Keep helping me. Keep helping me. What will be the column number? What will be the column number? What will be the column number? Everybody, yes, Thomas. Yes, please, Mandeep. Keep replying. Everyone, please keep replying. That is required actually for DSA. You need to think. You need to reply. This is all logical. What will be the value of column? Let's suppose we know that, okay, how many, what is the size of this matrix? M into n. M into n. So Karthik is saying that n minus 1. Karthik is saying that n minus 1 because indexing is starting from 0. So that's why he is saying that, okay, number of columns are 4. So that will be 4 minus 1. This will be 3. Or if we write in C++, I can write the code like this. I will share the code of Java and Python also. But just in the C++, how you can find out this thing? N is the number. How you can find out number of columns? Actually, that you can find out with this grid. 0 grid is the array name. Dot size minus 1. So this is telling me how many columns are there. This is telling me how many columns are there. Or if you don't understand C++, it's okay. You can write n, because we are talking about the logic only right now. Fine. Till now everything is fine. Now if statement I'm writing, if in my grid at this row and this column, if I get negative number, means which is less than 0, what I need to do? You already tell me, count all these elements. You already tell me, count all these. How to count? Count plus equal to count plus whatever you can write. What I need to write? How I will count all these elements? How I will get all these elements? You need to think now. How I will get all these elements? So like if you will be here, then you need to count these 2 elements. If you are here, you need to count all these elements. So can I write like this? So for more clarity, let me write like this. Count equal to count plus, can I write number of rows? Number of rows, in this case m is the number of rows, minus in which row right now I am. In which row right now I am. Is this work or not? Yes or no? Yes or no? Please reply. Is this will work or not? Already tell by wisdom. Wisdom already tell this thing. Yes, wisdom. Verify, please verify. Yes or no? Verify. If you are able to connect or not. That is important. If you are able to connect or not. Is this will be n minus row or m minus row? That should be m minus row. Yes, Vikalp, you are right. You people are getting connected. Yes, that's great. And if we are getting minus, you are moving this side. Column minus minus. Column minus minus. Great. And else, this time I'm not writing complete for positive. Simply you can, what you can do, if you are getting positive, then you don't will count this, just move down. Just move down. Moving down means row minus, row plus plus, sorry. Because row is at 0, that will be 1. So row plus plus, that's it. And you put all these 2 steps inside a loop. Can you give me the loop also? Can you give me the loop also? Loop condition also, if anybody can give me, I will copy paste over here. Last thing, how many times this loop will execute? See, column, this time is starting, column value is how much? Column value is n minus 1. Okay, and row is 0. So row should not cross, should be until unless row is less than total number of rows. Total number of rows are m. Okay, and column, you are decrementing the column. So right now column is n minus 1. So until our column is greater than equal to 0. Until that is greater than equal to 0, we'll keep moving on. or until our row is less than m, we will keep moving on. That's it. So yes, if we are considering this, if you are starting from here, this is the code you can write. This is the code you can write. You can this will also work fine. Any doubt in this? Any doubt in this? Yes, Vikalp, you are actually right. Just need to write equal to also, because zeroth column also we need to count. Fine. Any doubt in this, you can ask me. Otherwise, again, I will ask you one question from you. You people ask me the question, otherwise I will ask. Otherwise, I will ask. So let me ask you one question, if you really understand. Why? Okay, we need notice that if I'm starting from here, working fine. I can solve this problem in order of n plus m time. If I'm starting from here, yes, I can solve this problem in n plus m time. What about? Can I solve this problem if I start from here? Yes or no? Verify yourself. I cannot go to your brain and I cannot build the logics until unless you will not think. I'm asking the question. I can just ask the question from you people. I'm asking the question. If I start from here now, we started from here working. We started from here working. I'm asking the question directly now. If I start from here, can I solve this problem? Can we use the logic, this logic somehow, and can we solve the problem? Yes or no? Yes or no? The question is, can I start from here now? And can I solve this problem? Yes or no? Please reply in the chat box. You need to think yourself. I cannot think for you. That is required. If you are thinking or not. I don't know if you are thinking about your girlfriend, maybe. How I can predict this thing? You may be pretending that, okay, to your parents that, okay, we are thinking about the problem. But your parents may get immediately will catch you. Immediately your papa will slap you. You're thinking about your girlfriend, you're smiling. Mandeep is saying yes. What about yes? About the slap or what? We cannot solve. We cannot solve this problem if we are starting from this location. We cannot solve this problem if we are starting from this location. Why? What is the reason? What is the reason? Some people are saying, Thomas is saying no. So Thomas, any reason? No, means I'm saying, can you solve this problem in this much time? If you will go one by one, yes, you can solve, but that will take n into m time. I'm saying this with this logic. Can you use this logic and solve by starting from here? No. Why? What is the reason? What is the reason? The reason is that, see, we need to skip the elements. We need to skip the elements. If I'm starting from here, I cannot take the benefit of sorted array. I cannot take the benefit of sorted array. Why? The reason is that if this number is positive, okay, this number is positive, then what is the prediction I can make? Can I take any decision about these numbers? Can I say, okay, all these numbers will be positive or all these numbers will be negative? I cannot take this decision. I cannot take the decision here also, in the same column also. I cannot tell if this number will be negative or positive, because this is in decreasing order. I don't know, maybe these all can be negative, maybe these all can be positive. I don't know, because I'm starting from the first element. If let's suppose if I give you decreasing order series and I give you first element, and then I ask you which are the element will come after that, that will be negative or positive. We don't know. That can be positive, that can be negative. So we cannot skip the elements. From here I was able to skip the elements, because if the number was negative or positive, if the number was negative, I was adding directly all these elements. I was skipping all these elements. I was directly adding them. And the number was positive, I was skipping the left side element, because I know that left side element will be also positive. But in this case, if the number is negative, I don't know. If the number is negative right now, so okay, then I can say that, okay, all these are negative. If this number is negative, okay, if this number is negative, then this will be decreasing. So this will be negative. This also will be negative. Actually, all array will be negative. or array will be negative. One case you can say that if this number is negative, if this number is negative, then total number of elements, that will be the, in order of one you can solve the problem. Actually, in order of one you can solve the problem, but for positive you cannot take any decision. Okay, for positive now you cannot solve the problem. Okay, so what I'm saying, okay, I'm repeating once again, I cannot take the decision if the number is positive, because I don't know either move to the right side or downside, because I don't know where will be the next negative. I cannot apply this logic over here. But one case is coming over here. If this is negative, then all will be smaller, this side also, this side also. So I can say that, okay, uh, can I say this thing, okay, you verify if this number is negative, if first number is negative, this number is negative, I'm making a statement, you please verify, keep verifying. If this number is negative, can I say that number of total number of negative elements will be m into n? Can I make this statement, yes or no? Yes or no? If this number is negative, then total number of elements will be m into n. Negative elements will be m into n. Can I make this statement? Keep verifying. Keep verifying. If this number is negative, yes, Thomas say yes, Wisdom say yes, Karthik say yes. Okay, one more question then. If you really understand this logic, I'm asking last question, okay, from here. Last question from my side. If this number is positive, then what is the statement I can make? What I can say? What you can predict? If this number is positive, what you can predict? If this number is positive, last number of the matrix is positive, then what statement you can make? How many, can you tell me how many negative elements will be there in the matrix? How many negative elements there will be in the matrix? Yes, all elements will be positive. All elements will be positive only, because this is decreasing. If this is positive, then all these will also be positive. And this is positive, this is positive, this is positive, this will also be positive. So number of negative element will be 0. You might use that thing, you but that might be okay, one case only, but this will not solve the problem. So I cannot start from here and here, but yes, 2 points may be coming here, directly we can make two decisions. The problem can be solved from here and here. Yes, yes. So I hope this idea is clear to you. Let me share the Java code also with you people. So the people who are from Java background, they can, I think, check out this code. So let me share the Java code. So this is the same thing you can see here. Uh, in this, actually, let me write. We are starting from bottom left corner, in the matrix. So you can see that on which row we are at the last row. This is the last row and first column. So this is the bottom left corner actually, and this is calculating number of columns, total number of columns that will be requiring us. And this if condition is checking the negative case when the elements are less than 0. This is checking the positive case when elements are greater than or equal to 0. Then we are not counting anything if the elements are positive. We are just moving to the right side. Otherwise, we are moving to the upside and counting total number of negative elements if we are getting elements less than 0. And we are executing this loop until we are either crossing the column or we are crossing the row. That's it. The same thing, just in the Java. And if we are looking for Python, so the same thing in Python. See, last row, first column, 0th column, and this is telling me total number of elements in a column, and count is set to 0, and same loop, and negative, this is negative less than 0, this is checking for positive. Here we are counting same way and we are returning. So this is for Java people. This is for the Python. Who are in Python? This is the code for Python. Fine. The idea is that the main idea is about the logic building. It's not about the language that much. That will not create a big difference. Okay. Okay. So now let's take your ideas. Let's take your ideas. Let me go first by the binary search. Okay. Someone was, I think who was talking about the binary search? I think Bharat was talking about the binary search. Can we apply the binary search over here? So let's see if we can apply binary search. So maybe how we can means apply the binary search over here. So might be you are saying that converting from 2D to 1D first. Matrix is sorted in such a way that this matrix is sorted in such a way that this is in decreasing order. This is in decreasing order. And elements can also be same actually. So that is known as non-increasing. So you can replace this, okay, to remove the confusion, decreasing. So only difference between these two is that, okay, this allows the equal to also. This do not allow equal to. Non-decreasing allowed equal to also. So equal to is also there. So yeah, this is in sorted order. Okay. Yeah, fine. Okay. So first of all, okay, let's talk about the binary search. Can we apply the binary search over this? How we will apply means? So might we can think over it. So we are searching for the negative elements. We are searching for the negative element in this. So maybe we are comparing with the middle element. Then we are finding the negative elements. Okay, that will take log n time. Okay, log n time to find out. You can say, okay, log f. How many elements are there? N. So to find out the one negative element which is at the leftmost side, that will log n time. Here also that will take log n time. Here also log n. Here also log n. So this will be actually how many rows are there? M rows are there. So for every row that will take log n time. This can be one idea, means you can apply log n, find out the negative elements. So this you find out in log n time. This you find out in log n time. The people who don't know about binary search, it's okay. That we have not covered till now, but the people who already know, I'm talking about that. Binary search actually take log n time to find the element. So we are finding the negative element. So here we find out the first negative. After that we can calculate total number of elements in constant time. So every time I'm taking log n, log n, and log n in every row. And how many rows are there? M row. And every time I'm taking log n time. So that will be m into log n. And m into log n is actually greater than n plus m. So I can say that this idea will work fine, but this is taking more time than our optimal approach. Our optimal approach. And once one person was talking about, okay, another thing that, okay, what if we convert it from 2D to 1D? So if you will write it from 2D to 1D, okay, let me write 3, 2, 4, 3, 2 minus 1. After that, this 3, 2, 1 minus 1. If you will write in this format, then how you will use the concept of sorting? So there is no concept of sorting now you can apply. Means, see, after minus 1, 3 is coming. How you will apply the, if you cannot apply the, if you cannot take the benefit of sorting, then how you will reduce the complexity? So one of you was saying that, okay, what if we convert it from 2D to 1D? So if any other thing is in your mind, you can share. Otherwise, I'm facing the problem that, okay, if we are converting from 2D to 1D, how means you will reduce the complexity? Because even you are not using the benefit of sorting, because the array is not sorted now. Array is not sorted now. And if we are checking each element again, okay, Vikalp is saying checking each element, then that will Vikalp, that will reach to the time complexity m into n. But that will reach the complexity to m into n. Yeah, in 1D array, 1D array, total element will be how much? That will be 16. So this will take 16 steps to 16 means m into n, 4 into 4, and we will take this much time. So we can find out the solution, but this is taking more time. This is taking more time. Even we do not need to convert to 1D. We can just search into the 2D itself, but that will take m into n time. Okay, we call. Okay, that's it for today actually. So yes, we completed our next session also. Let me raise the board and show you this GIF so that you can also enjoy. We are on the way to complete our DSA series. This was our sixth session, and remaining 12 sessions are remaining. We will go with that also. I hope you people are getting benefited from these sessions. Let me tell you one more thing. This is the foundation course. This is the foundation course. Okay, I'm building the foundation right now. I will come up with the advanced DSA course in which I will cover each and every point from every topic. Right now, this is about the foundation. This will also help you a lot. This will help to build your foundation. The name is given foundation. And after that, we will come up with the advanced problem. Thomas is asking for the homework question. I will share the question into the comment section. Okay, I don't have right now. So I will promise I will share the question in the comment section, and I will share the solution also in the comment section. Vikalp is asking, okay, tell about the college CGPA. College, if you are targeting for product-based company, Vikalp, CGPA doesn't matter. CGPA doesn't matter. I can make a line from here. I'm right now in Bangalore. I can make a line. I can say that you people, BTech people, start standing from here. I can make a line till the Delhi. Till the Delhi, I can make a line of people who are having more than 70% in their BTech. I can make a line, but they are not in any product-based company. CGPA will be left behind if you are good at problem solving, if you are good at DSA. The reality is that they need the people who can solve their problem. They are not there to check if you're some actually if there are lots of private universities are there, they are giving the marks randomly. Okay, how they will compare means one private university from other private university. One is very strict about the marking, one is very means lenient. They don't want to, they want good marks from the student. They are making fool of the students actually. They are giving good marks, and students are their kids only, just like they are kids only. They write at that time, they don't understand, but the college management is making fool of them. They are giving good marks, and their kids only. They are thinking, okay, we get good marks, but actually that is not going to help them to get the job. It's better to tell them right at the same moment, you need to improve. The people are getting 80%. The people are getting 80%, and at the end they are not getting job. At least tell them, you are not right now ready to get the job. You need to improve yourself. You are giving them 80% marks, and he is now relaxed that, okay, I'm getting 80% marks. I do not need to improve myself because I'm getting 80% marks. There also means right at their place. You have to tell them, you don't deserve the job, so that he can improve himself. So CGPA is not going to make the impact. Maybe if some companies are coming to your college, they can ask about the CGPA, because if they are coming to your college right now, okay, they are coming to your college, they want to differentiate. Okay, now they can differentiate. In off campus, CGPA will not make that much impact. After 1 or 2 years, that will completely out of the boundary. Nobody will ask after 1 or 2 year in industry. And if you are targeting for product based company, do not need to do not need to worry about the CGPA. Just focus on your logic building skill. Okay, that's it for this session, and we will meet tomorrow with the next session. Thank you everyone. If you are liking this series, if you are liking this session, if you are getting some information from these sessions, please write that into the comment section. Please like the session so that this can reach to maximum students. Fine, okay then. Thank you everyone. Thank you Lokanath. Thank you everyone. Bye bye. Take care. Good night. I'm now ending this session.